All right, it cut me off on number 5, and I accidentally said vertical when I was totally drawing a horizontal line. But just to quickly recap number 5, undefined is a vertical line. A slope of 0, 0 divided by anything is 0 is horizontal. We talked about how those not parallel, those vertical and horizontal lines intersect at a right angle. So for number 5, it would have been that perpendicular answer. So that was 5, just to wrap that up, and I wanted to clarify that. So moving on to number 6, practicing these skills here. Finding the slope of AB and CD again. So m equals y2 minus y1 divided by x2 minus x1. So that became minus negative plus a positive. 6 minus 7 is negative 1. Negative 2 plus 4 gives me a positive 2. So our slope is negative 1 over 2. CD, m equals y2 minus y1, so minus a negative becomes plus a positive, divided by x2 minus x1. So 5 divided by negative 10. This is a situation where you might be like, oh, they're different. There's no relationship. It's neither. This is why I've stressed along so far this unit. You've got to reduce slope as much as you can in order to make these connections. So for 5 and negative 10, 5 goes into both of those. 5 divided by 5 is 1. Negative 10 divided by 5 is negative 2. So negative 1/2 and negative 1/2, even though how I ended up simplifying that negative's in the numerator and here it's in the denominator, we're good. Don't worry about that. They're both negative, it's the same sign, and it's the exact same fraction. So regardless of where that negative falls in your fraction, it just means it's a negative fraction. It's okay. Same, these would be parallel. And when you're writing parallel, remember it has the word all in there so you don't get confused on where your L's go. All right, number 7. And if you've got this, like I've mentioned before, just pause me, work them out, and then speed through this at a quicker pace to get to the end when my problems, then to check your work. And then you can go back and make any corrections as needed if you need that. All right, A, B, and C, D. So we've got M equals negative 4 minus 1 divided by 3 minus 3. So that's going to give me negative 5 over 0. Anything divided by 0 gives us that undefined, that vertical line. And I just think it's good to keep making that connection. The slope of undefined is vertical, just so you keep having that visual image in your head. For CD, we've got, I'm going to set it up right and write M equals, just because we've been doing so well about keeping our work organized so far. M equals y2 minus y1 over negative 4, which is x2, minus a negative 4 for x1. So that's going to become plus. That gives me 4 over 0. Even though those numerators are different, anything divided by 0 comes out to be undefined. So these are going to be two vertical lines spread out on our graph. Those vertical lines are never going to intersect with one another. So these would be parallel. Even though the numerator is different, once you're dividing by 0, they're coming out undefined, giving you that same relationship. Perfect. One more in this section, so I'm on number 8 in your notes. A, B, and C, D. We'll move on to something else for the last section. So A, B, M equals 2 minus 8 over 3 minus a negative, so that becomes plus 3, giving me 2 minus 8 is negative 6. 3 plus 3 is 6. Reduce that to just negative 1. If it helps you to leave it as a fraction, you can leave it as negative 1 over positive 1 if you like, but you don't need that. Okay, CD. We've got M equals negative 1 minus 1 over 5 minus 7. So we're going to get negative 2 over negative 2, which cancel out to give me a positive 1. Different signs. One's positive and one's negative. So that's meeting the opposite or negative criteria that we need. But how do you know it's flipped? Is it a reciprocal? Well, isn't 1 over 1 just the same as 1 over 1? So yes, these are going to be reciprocals. One's positive, one negative, meeting that negative or opposite requirement. So these are perpendicular. The longest word to write. All right, so that section is done. We're going to move into that given equation sections for 9 through 16. All right, so you're going to notice a mix of variations of types of equations that are given. Some of them we're not going to have to do any work because they're already going to be done for us. Some of them we're going to have to do some rearranging. So if you're looking at number 9, they're giving you two equations. Y equals 7x plus 2 and y equals 7x minus 1. Doesn't matter what the y-intercept is. All we've been focusing on in order to determine parallel or perpendicular is the slope. Both of these equations are in what form? Slope-intercept form, y equals mx plus b. M is slope. So for number 1, the first equation, m equals 7. That's our slope. Well, for the second equation, m also equals 7. So are these lines parallel, perpendicular, or neither? They're the same. They are parallel. So all I would expect to see for your work is that you're somehow identifying that you see that both of the slopes are 7 and then making your justification based on that. So this is an example of minimal work, just identifying what's in front of you. Going across to number 10, both of our equations are once again given to us in slope-intercept form, which is really nice of them. So I've got y equals 4 over 5x minus 8. And y equals negative 5 over 4x plus 3. So here's my slope, and each of them boxed in. One's positive and one's negative, so I know they're not parallel. 4 over 5, if you flip it, you get 5 over 4, so this is your example of perpendicular. Opposite reciprocals. I'm just boxing it in. I'm fine if you're doing that. Maybe you're going to just write it underneath the equation on your paper too. That's also fine. Somehow giving me information that you know where the slope is in that equation and then how to draw that conclusion of parallel, perpendicular, or neither from that. All right, number 11, y equals negative 1/3 x plus 2 and y equals 1/3 x. So the first one, m equals negative 1/3. And in the second one, m equals positive 1/3. So they're not parallel because they don't have the same sign. But they're also not reciprocals. 3 over 1, they didn't flip it to get that. I don't see that anywhere. They're both 1 over 3. So this is an example of neither. Not parallel because they have different signs, but they're not perpendicular because it's not a reciprocal. So this would be neither. All right, great. So 12 is where we got to do a little bit of work because both of the equations they're giving us are in standard form. Remember, ax plus by equals c? At least, actually, I lied. The first one's in standard form, but the second one is just not fully isolating y, so we're going to have to do a little work. But that's not in standard form necessarily, just the first one. So in this one, we're going to just work these out so I get x alone in each of them, so I'm able to identify what the slope is. 30 divided by 6 is 5. Negative 1x divided by 6 is negative 1 over 6x. This one, I only have to do one step here, which is just divide by that 3 on each side, so y is by itself. 18x divided by 3 is 6x, minus 6 divided by 3 is 2. So my slope in this one, m equals 6, and my slope in that first one, I'm going to back up, m equals negative 1 over 6. So one's negative and one's positive, so they're going to be different signs. 6 is a fraction of 6 over 1, so they are reciprocals. So this is going to be perpendicular, opposite or negative reciprocals. All right, 10 is done. Moving on to 11. All right, so we just did number 12, and now we're going on to number 13. Sorry, I just had to pause and restart it, so hopefully I'm on the right one. So in number 13, both of these equations are in different forms. So the first one actually is in standard form. That second one's in slope-intercept form. So cool of them to do the second one like that because that one's easy. I know my slope's going to be negative 1 over 5, just taking that m value, whatever coefficient's in front of the x. Over here, I'm going to have to do a little bit of work. So I'm going to subtract that 5x on each side of my equation, Remember, that subtraction sign is going to be treated like a negative in front of that y right now. And then negative 5x plus 4. And if you did 4 minus 5x, it's the same thing. You have to divide by that negative. So I'm going to divide both sides by negative 1. Negative 1y divided by negative 1 is just y. Negative 5 divided by negative 1 is positive 5x. Don't forget my x. And then 4 divided by negative 1 is negative 4. So my slope for this one is 5. M equals 5. So I've got opposite signs. This is positive, this is negative. And 5 is the same as 5 over 1, which is the reciprocal of 1 over 5. So this is another example of perpendicular, like number 12 was. Number 14, both of these ones now are in standard form. So we're going to have to show our work. 3x minus y equals 2, and 12x minus 4y equals 4. Okay, so minus 3x on each side. Negative y equals 2 minus 3x. Divide by that negative. Don't forget to do that because that's going to mess up your signs, which is crucial when identifying positive and negatives with either parallel or perpendicular. So this one I'm going to get a slope of 3. Pulling that out, the coefficient in front of the x. All right, rearrange my second one. So minus 12x on each side. Negative 4y equals negative 12x plus 4. Running out of room here. That's a negative 12x plus 4. Let's see if I can fit that in. 4. Okay. Divide by that negative 4. Y equals negative 12 divided by negative 4 is positive 3. X minus 1, 4 divided by negative 4 is negative 1. Slope would be m equals 3. Beautiful. They're both positive. It's the same number. Parallel example. So showing this work is my understanding that you know how to get from standard form to slope-intercept form, just like we practiced earlier on in the unit. And then the new piece of information is, oh, looking at those slopes, when I graph these two lines are never going to touch. They're going to be parallel. Awesome. We have 2 more to get through, numbers 15 and 16, and they're going to be a little different, and I'm going to refer you back to actually the first video lesson I did with you guys on vertical and horizontal line. Actually, no, not yet. That's going to be for 16. 15's not. 15's just reviewing how to understand that 1 and negative 1 are reciprocals. So these are both in slope-intercept form. So my slope for the first one is just 1. That's like 1x. Or write it as a fraction, 1 over 1. The slope for my second one, if you want to add a negative 1 in there, m equals negative 1, or negative 1 over positive 1. Remember, only one negative. If you put 2, they cancel out. So they're opposite signs, so I know they're not going to be parallel. The reciprocal of 1 over 1 is just 1 over 1. So these are reciprocals of one another. Opposite reciprocals mean that this is a perpendicular relationship. And for some reason, 1's the most simple number, but when we're working with knowing that they're reciprocals, it gets a little confusing, and so this ends up being more challenging for some of us. All right, now number 16 is the horizontal and vertical example. Let's jumping ahead before. So 16, y equals 6, and x equals negative 1. So y equals is what we're used to seeing with slope-intercept form, but there's no x, so I don't have a slope. Y equals, is that a horizontal or a vertical line? So if you go up to 6, if I have a coordinate plane, if I'm at 6, and that's it, I'm not going to leave. I'm not going to go any higher or lower than 6. That's going to be a horizontal line. So the horizontal lines have a slope of 0. M equals 0 for this. So x equals negative 1. It's never going to move left or right from that negative 1. So that's going to be a vertical line. So the slope of a vertical line, remember, is undefined. Right angle, this is the example where we don't use opposite or negative reciprocal, but we know 0 and undefined are horizontal and vertical lines. This is a perpendicular relationship. If you had 2 vertical lines, they would be parallel. 2 horizontal lines would be parallel. When you have one of each, it's perpendicular. All right, not my best video lesson, so I apologize. It was a little scattered, but all of your parallel and perpendicular line notes should be done. This is going to be considered day 1, so you're going to be getting homework 9 from me, and it's actually going to say day 1 on the homework. It's one One-sided is the homework, and then you have a coloring on the back.